Hello everyone. Today's topic is related to IGCSE Chemistry Chapter 2, The Nature of Matter, Part 1. Let's look into Chapter 2 outline. We will study about chemistry and its importance, chemistry history, chemical use in daily life, common chemical use in everyday life, chemistry-related career, scientific method, atoms and molecules, the state of matter atom, the states of matter molecule, the state of matter ions, descriptions of three states of matter, differences in property of three states of matter. Let's begin. The meaning of chemistry. Chemistry is the branch of science that deals with characteristic and composition of matter. Chemistry is the study of the composition and structure of matter and the changes it undergoes. When a chemical change takes place, the chemicals produced are quite different from the starting materials. Example, iron metal slowly react chemically with the oxygen in the air to form rust. Rust is quite different from the original metal. When fuel is burned, a chemical reaction takes place, releasing energy that can provide power for vehicle transport. At the microscopic level, the study of chemistry involves the analysis of the structure of atoms and molecules. Atoms and molecules are the fundamental unit of matter on which the study of chemistry is based on. The study on atoms and molecules enable the scientific design of new substances with specific properties such as drugs and environmentally friendly consumer products. There are three main branches of chemistry. First, inorganic chemistry, which is the study about specializes in substances without carbon. These are mainly substances from non-living things. In physical chemistry, this branch specializes in the description and behavior of chemical substances, and biochemistry is actually chemistry that deal with composition of living organism. Let's look into root of word and gallery. Chemistry originated from the Egyptian word chemia means black. Nevertheless, some people are of the opinion that word chemia originated from Greek word called chemos. The Arabians were among the early chemists. They called chemistry alchemia. The knowledge of the Arabs' chemistry was further developed by British. 500 years ago, people who studied chemistry were called alchemists. Many alchemists, not chemists, many alchemists tried to change metals into gold, but they were not successful. Let's look into chemical use in daily life. Chemistry is everywhere. Anything that you can touch, see, smell, contain one or more chemical substances. Many chemicals occur naturally, but some synthetic. Chemicals are present in food, medicine, vitamin, glue, clothing, paints, household cleaning product, and everything else around us. Chemical can be both useful as well as dangerous. Some chemical can save life, others can be lethal. Let's look into some of the common chemical use in everyday life. Ammonia is used to make fertilizer and explosive. Aluminium hydroxide as an anti-acid for gastric patient. Calcium carbonate is to make cement. Calcium sulfate as a plaster to support broken bones. Ethanoic acid as a preservative and as a food additive. Chlorine is a water purification and to make poison and bleaching agents. Ethanol as a liquor and food additive. Formaldehyde is to preserve biological specimen. Formic acid is to coagulate latex. Magnesium hydroxide is toothpaste to neutralize acid. Nitric acid is to make fertilizer and explosive. Silver bromide is to make photographic film. Silver chloride is to make photochromic glass, sulfuric acid, lead acid accumulator, battery, sodium benzoate as a food preservative, sodium chloride in cooking and preserve food, sodium hydroxide is to make soap, urea nitrogen fertilizer, windy chloride is to make water pipe and insulator. Chemistry related career. You can see you can be as a food science, geology, genetic, ecology, chemical, or you can be involved in chemical industry, doctor, dentist, pharmacist. You can work in the petroleum, steel industry, palm oil industries, and many more. Scientific methods. Scientific methods is a systematic method used to solve problems in science. The scientific method involves the steps below. First, making observation. Second, making inference. Third, identifying problem. Fourth, making hypothesis. And then identifying variable, controlling variable, explaining or planning an experiment, collecting data, interpreting data, making conclusion, and writing report. Let's go through the meaning or how to conduct for each of these scientific methods. Making observation is maybe or can be classified into two. One is a qualitative, which is descriptive. Example, you have to describe water is a liquid, the sky is blue. Your observation must be in a descriptive. And the other one is quantitative. Means that with measurement. Example, water boil at 800 Celsius. Observation involves the use of senses such as seeing, smelling, touching. Making inference means that once you have made the necessary observation, you often try to interpret or explain them. So interpretation or explanation involve making inferences. Identifying problem is many questions in chemistry begin with these 6 words: why, where, what, which, when, and how. So during the process of making observation, you will need to ask questions to yourself. Example, why firecracker explode when ignited? So, and then you have to make hypotheses to explain things. We sometimes make guesses. A good guess is called hypothesis. A hypothesis is a possible explanation for an observation. Example, you observe that iron nails rust faster in a wet area than in dry area. So you have to explain this. An observation, you may say, I think the process of rusting needs water. So this is your hypothesis. Hypothesis have to be tested. This can be done by making a prediction or doing an experiment to see prediction is true. Then you have to identify variable. During scientific investigation, you need to decide what you are going to change. The things that you change are called variables. You can have to identify the manipulated, responding, and fixed variable to test your hypothesis. Controlling variables means that you have to decide how to manipulate the variable you choose, what to measure, and how to keep the fixed variable constant. Planning an experiment is carried out to test hypothesis, which is involved gathering new information that enable scientists to decide the validity of the hypothesis. Experiment always produce new observation. Learn how to make observation and record the result. While doing experiment, you will need to do some of the following, like writing sentences on your observation, drawing diagram on what you see. For measurement, you have to use table, graph, chart to record your data, and you need to select suitable apparatus. Collecting data. The data collected from your observation and measurement made during experiment must be recorded systematically. And you have to interpret the data. Data must be organized and analyzed. Interpret data using graph, chart, or by calculation. And then finally, you have to make conclusion and writing a report. Conclusion is a statement made from your experiment, and then you have to write a report to communicate about your experiment. Let's look into atomic structure. Okay, if you can see, atomic structure consists of electron, which is the outside, they call it electron orbit, and inside there is a nucleus. Inside the nucleus means that it consists of proton, neutron, and the outside, in the orbit itself, it calls the electron. What is actually the atom? Atom is actually the smallest particle of an element that can participate in a chemical reaction. So, the sample of individual atoms is like hydrogen and oxygen. Proton number is the same as number of proton. Or nuclear number is the same of neutron plus proton. Valence electrons is actually the electron in the outmost shell. And compound means that contain two or more different elements combined chemically. Atom combine to form molecule. For example, if you can see phosphorus, these four atoms, we call it as P4, so consists of four atoms, which is formed. The four atoms combine to form molecule. Molecules is actually two or more atoms chemically combined together. Okay, for example, you have water, H2O. Okay, this is hydrogen, this is oxygen. And ion, positive or negative particles. When you have positive, it's a charged ion. Minus is actually a charged ion. Atoms and molecule, the state of matters. Matter can be defined as anything that has mass and occupies space. Matters may be something which can be seen and felt, such as book, or something which is difficult to be seen or felt, but still exists, such as air. Matters is made up of tiny, discrete particles, that is, matter exists in a whole particle and not as half or quarter particles. Particles that made up matters can be in the form of atoms, ions, or molecules. Example, iron is made of particles called iron atoms. Sodium chloride solution is made up of particles called sodium ions and chloride ions. Water is made up of particles called water molecule. In this table or in this diagram is just to show you the arrangement of particles in solid. You can see in solids, this is in liquid and this is gases. Atom. All matter is made up of atom. Different substances are made of different type of atom. Atom is the smallest of an element that can take part in a chemical reaction. Atoms are so small that they are not visible to the eye. Only the biggest atoms, such as uranium atom, can be seen as a blur outline on a photograph taken with an electron microscope. The atom of an element has its own name and chemical symbol. Example H is the symbol for the hydrogen atom, and O is a symbol for oxygen atom. Molecules. Molecules exist as particles. Molecule contain two or more atoms which are bound together. The atoms that are bonded together may be of the same kind or of different kind of element. The atoms that are bonded together may be of the same kind or of different kind of element. Example, hydrogen molecule, H2, consists of two atoms. You can see a molecule of hydrogen consists of two atoms of hydrogen bonded together. An example on the right hand side is tetrachloromethane, CC4. So if you can see, CC, you have C, big C, and Ci, you have 4. CCI4 molecule consists of one carbon atom. Okay, this is one carbon atom, the biggest one in the center. and 4 chlorine atoms. Chlorine atom bonded together. Okay. Ions. Ion exists as particle. Particles of ions are charged either positively or negatively. Example, sodium ion and magnesium ion are positively charged ion. Bromide ions and nitrate ions are negatively charged ion. Ions are formed in liquid state or in the molten state. When an atom loses one or more electrons, it becomes a positive ion. When an atom gains one or more electrons, it becomes a negative ion. This diagram essentially tries to explain about each sodium atom loses one electron to become a positively charged ion. The kinetic theory attempts to explain how solid, liquids, and gases behave. The theory is based on 3 assumptions. All matter is made up of tiny particles called molecules, atom, and ion. All these particles are moving continuously and at random. When the particles are close together, there are attractive forces between them, and the movement of the particle of the substance is affected by heat. When the temperature increases, the motion of particle will increase too. The higher the temperature rises, the faster the motion of the particles. The effect is much bigger for a gas than for either solid or liquid. The freedom of motion is also affected by the intermolecular forces between the particles. Okay, you can see the different types of molecule. If you can see at the solid in a strong forces of attraction hold the atoms or molecule together in a regular pattern. Thus, the particles of a solid are not able to move freely. So the particle of a solid can only vibrate, but they cannot break free. Solid has a fixed shape and volume. Likewise, as you look into liquid, in a liquid, the molecules are further apart compared to the molecule in a solid. So the particles are not arranged in a regular order as those in solid. The distance between the neighborhood particles is further than that in a solid. So there is also a space. Okay, and the force of attraction is weaker compared to a solid. Thus, particles of a liquid can move around easily than solid. Liquid take the shape of a container. On the surface of a liquid, the molecules attract one another, like gases. Gas molecule further apart from each other than molecule of solid and liquid. You can see from this diagram, there is a lot of space in between the neighborhood. No attraction between particle of gas. Gas particle move faster and move freely than the particles in the solid and liquid. Gas particle move zigzag pattern. So gas particle collide with one another and collide with the wall of the container. Okay, if you can see, this is the state of matter, solid, liquid, and gases. If a density solid is considered high, liquid is moderate, and gases low. Compressibility, solid, none. You cannot compress. Liquid, almost impossible. Gases, possible. Shape, solid, yes, you have a definite shape. Liquid, follow the shape of container. Gases, none. And volume, solid, definite. Liquid, definite. And gases, no fixed volume. Or expand to fill the container. Diffusion, solid considered the slowest, and diffusion in the liquid is a moderate fast, and diffusion in gases the fastest. So this table is actually to show you the differences in the properties of the 3 states of matters. With that being said, thank you very much for your time. Just to let you know, if you still you still need the notes about this chemistry. You can find this note through clicking the link at the Instagram under Jom Study Lab. So there will be more notes updated in the future. So including chemistry notes, we will update, and also the biology notes. So you can look into this link. So with that being said, thank you very much.